Hello y'all, we are Memphis Communiversity and today we are doing another calculus done wrong lesson where we run calculus before calculus wrongs us. And today what we're going to be doing is we are going to be doing limits. And I know you're thinking limits, ew, they're the worst, they're the worst, they're the worst. And they sort of are the worst, but I have good news for you. Instead of doing the limits that we might have done in the past, the methods that we employed in the past, like multiplying by conjugates or factoring or expanding or fractions, blah, 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 we're going to be doing something different. We are going to be changing these questions that we despise, these limits, into questions we actually love, or at least I love. We're going to be taking derivatives because some limits are by definition derivatives because derivatives are the limits of different quotients, limits of slopes. So let's talk about that. Let's write down the definitions of derivatives as limits, and then let's see the power of that because we're going to be changing limit questions into derivative questions. So we are talking about derivatives as limits or limits as derivatives, whatever way you want to see it. So there's going to be two definitions here, but again, it's just slope. We actually talked about this in a previous video when we introduced derivatives for the first time. But as a review, the first one I'm going to call the non-h one. So it's going to be limit as x goes to a, f of x minus f of a over x minus a. So I apologize. I've been writing the three characters LIM, which stand for limit, of course, so many times that it sort of devolved. This is how I write it now, after several years of doing this. But again, it's just slope, y2 minus y1 over x2 minus x1, and you let the x approach whatever number you want. The second way, which is going to be called the h1, because it has an h, is going to be this one right here. So it's going to be the limit as h goes to 0, h f of a plus h minus f of a. This is still slope, and basically again, we're letting this h be 0, so we have these 2 points and they're coming together, so that eventually you're finding the slope at that exact point. But we're not really thinking about the derivative sort of in a graphical interpretation. What we're doing here, we are doing limits. So what we're going to do is we are going to see two limits. We're going to see limits of this form, and what we're going to do is we're going to not evaluate the limit in this traditional way, the pre-calc way, what I said. We're going to do it the calculus way. So we're going to identify that there are derivatives. So the steps are going to be this, and I'm going to repeat this over and over and over again because I like to hear myself talk. But what we're going to do is we're going to identify a function. We're going to identify a number. We're going to take the derivative of that function, and then we're going to plug in that number, and that's going to be the answer. So we're going to take these limit questions and change them to derivative questions. So let's see how that works. So I'm going to rewrite our definition of derivatives as limits sort of on the top here so that we always can make use of them. So this is the first one. This is the not h one. Let's see how fast I can write it. So it's this one. And then the h one looks like this. So there's h on the bottom. And we're good to go. So let's do two examples that will give us the same answer, but just one for this one and one for this one, just to start off. So I'm going to do limit as x goes to 5 over x minus 5, x squared minus 25. So this is going to be my first limit, and then my second limit, two separate questions, but it's nice to see them done back to back. It's going to be this limit as h goes to 0, h on the bottom, x plus 5 squared minus 25. So two beautiful limits because we're not actually going to have to do the limits. We're going to change these to derivative questions. So let's talk about the steps. Again, the steps are not too bad. Just identify two things, the function and the number, and then take the derivative of that function, plug in the number. So let's take this one first, the not h one. In my opinion, easier. So the identifying is very, very easy when you're doing the not h one. Because notice the f of x is sitting right there. It's looking at us. Even if we try to cover our eyes, it's still looking at us. It's like the Mona Lisa, right? This function is always just sitting right here. It's just x squared. Then we have to identify a number, but the number is even easier to identify because this actually appears twice. It's whatever the number x is going to, and it's the number that's getting subtracted from our x here. So in this case, our number is going to be 5. A is equal to 5. So again, let me just repeat that. Function right here, top left corner. A, two spots, you can find it here or here. So now that we have that, what you can do is you can just cover up that limit because we hate limits. And what we're going to do is we're going to take this information right here and just evaluate that limit without actually having to evaluate it, if that makes sense. So what we're going to do is we're going to take the derivative of this function and plug in 5, because this limit, by definition, is a derivative. So it's going to be f prime of x. Let's take the derivative. This is just going to be the power, of course. You've taken the derivative of x squared. It's 2x. Then we're going to plug in the a here, the number we identified earlier. So it's going to be f prime of 5. That's going to be 2 times 5, which I believe is 10. I have 2 hands, so I believe that is correct. So again, this is the answer. Let me repeat the steps. Identify the function, identify a point, take the derivative, plug in that point, you're good to go. Lovely. So it's going to be the same thing with the h way, but same sort of identification, same derivative, same plug-in. But let's just see how it's slightly harder. So we're going to take this guy right here. This is not what the h1 is. This should be an h, by the way. Sorry about that. But when you're doing the h way, there should be no x's because there's no x's in this formula. I just miswrote it. But now that we have it correctly written, let's just go for this limit. So again, what you need to do is you need to identify a function and you need to identify an a. So while in the non-h way, it's pretty easy to identify both, so you can really do it in any order. What I would encourage you to do in the h way is to first identify the a, actually. Identify the number. Because what happens is that the number is getting added to h. If you look at it, a plus h. So what number is getting added to h in this example? Well, it's 5. So again, I like to identify the number first because it's easier to spot. The function is slightly harder. It's not as easy as this one where the x squared are just sitting there looking at you. You do have to find it, but keep in mind that how you find it is you look for the number getting added to h. So in this case, it's 5 plus h or h plus 5. And what you want to do is you want to find what is that getting plugged into. So if we have h plus 5, what is that getting plugged into? Well, it looks like that's getting plugged into squared. Sometimes my students like to cover it up with an x and just read off the function. Looks like we're going to have x squared here. So this is x squared. Again, once you have the function, once you have the a, you can cover up the limit and you can just do the same process as we did before. You take the derivative, which is the same derivative, of course, it's the same function, and you plug in the point. Still 10. So no matter if you're doing the h way or the not h way, it's the same thing. Identify a function, identify an a, take the derivative, plug in a. For the h1, define a, look for the thing getting added to h. Then consider what that thing, that number plus h is getting plugged into. What function is that getting plugged into? That's f of x. And that's just all it is. 2 things before we move on to future examples. The first thing is that you can't apply this to every single limit. You only can apply this to limits of this form, this and this. Thankfully, these limits do appear quite often, so this is a method you're going to be using a lot on calculus exams like the AP exam, but it does have to be of one of these 2 forms. The second thing you want to be aware of is that there's one number we didn't really talk about. It's this number 25, so notice that in our work below, we did not have 25 ever. But what you can do is you can use it to check yourself when you're doing the identification step. So keep in mind that this number should be f of a. So what happens is that you can plug in your a is equal to 5, your number, into your function, the thing you think is the function, the thing you think is the number. Plug that in, and if it matches here, you probably are on the right track. You probably chose the right function, and you chose the right a, which is great. So some students like to check their work as they go. That's one way to check. This number won't be used, but it can be used to check whether you're doing the right thing. We could have done this easily by factoring and something like that, but let's do a question that's slightly harder where this method is definitely the better way to do it. So I'm going to erase this now right here, and let's do a harder one. So just erasing. Let's do a 1 with a square root. So I'm going to do limit as x goes to 81 over x minus 81 square root of x minus 9. So again, we had a non-h way, so it shouldn't be too bad. Let's identify 2 things, just 2, function and a. And it shouldn't take too long. The function is just in the top left corner. It's the thing involving x. So it looks like in this case, it's just square root of x. Square root of x. Then we identify the a, but the a is in two spots, so we shouldn't miss it. It's either whatever the x is going to, or whatever is getting subtracted to x. Looks like it's 81. Unlike before, hopefully you can tell that this is a 9 and not an 81, a. So I'm going to write this as 9, make it a little bit prettier. But let's use this number in this case. Remember that we're not going to use 9 to find the answer, but we can check if we're doing it correctly by plugging in this point into the function and hopefully getting this number. And it looks like we do. Square root of 81 is 9. We're good to go. So let's let our hair down. Let's just finish this question. Remember that when you have the limit, you can just cover it up. What you do is you just take the derivative of this function and plug in the point. We do have square root, so what we're going to do is our normal process, we are going to change that to an exponent because we love the power rule so much. So we're going to change this to x to the 1/2, fractional exponents. How crazy. So we have f prime of x. So let's take this derivative. Again, it's the power rule, that's why we change it to a power. Anytime you're using the power rule, you drop the power to the front like it's hot. So it's 1/2 x. Subtract 1, 1/2 minus 1 is negative 1/2. And then we're going to plug in 81. The power rule is great. It allows us to take derivatives very easily. So when we're taking derivative of square roots, or the next one when we're taking derivative of fractions, a lot of times we change things to power so that we can easily do the power rule to take the derivative. But once we're done with that, once we have to actually do math, when we have to plug in a number, for example, we'd like to change it back. So when we're going to plug in this 81, we're going to change this back. So it's going to be f prime of 81 is the answer. Looks like we have this 1/2 still. 1/2. And we're going to change this back. The negative exponent signifies that it's going to be in the denominator. The 1/2 means it's fractional, which means it's a square root. So it's going to be 1 over square root of 81. What is 1 over the square root of 81? Well, it's going to be 9. So it's going to be 1/2. Hopefully you can see this as I try to get out of the way. 1/2 times 1/9. What's the final answer? Looks like we're going to have 1/18. So let me squeeze that in here. Not very pretty. Forgive me, friends. But hopefully you can see sort of the process and see that the process is pretty easy. Identify a function, identify a point. The function sits right here. The point sits right here, the a or the number. Then take the derivative of that function, plug in that a, you're good to go. So let's do another H1 because H1s are a little bit harder. So I'm going to erase this guy. Love to erase. Favorite part of the job. So let's do this. Let's not erase too much. So let's do another H1. Let's do fractions because fractions are the worst. So we're going to do 1 over 3 plus h minus 1/3 over h. So how do we recognize that it's an H1? It has an h, also h is going to 0. Remember that I like to identify the function second, actually. I like to identify the a first. Remember that the a is the thing getting added to h. So it looks like in this case, it's 3. So we're going to write a nice little 3 here. Then the harder part is to identify the function, but you're always looking for the thing getting added to h. In this case, it's 3, and what that is getting plugged into. So what function is 3 plus h getting plugged into? Sometimes my students like to cover it up with an x. Looks like we have 1 over x. So we're going to have 1 over x. I don't know why I'm gripping the marker like this, but it's kind of fun, so I'm going to keep doing it. We can use this number to check ourselves. When we plug in 3, it looks like we do get 1/3. So it looks like we have chosen the right functions. So now we can stop looking at this awful limit and we can do derivatives, which are quite lovely in my opinion. But in order to do derivatives, just like in the previous example, we are going to change this. We're going to change it to a power because we want to employ the power rule because the power rule is our friend. So we're going to write it as x to the negative 1. We'll change it back when we have to actually plug in the number. So same step as before. Once you identify these two things, the f of x being the thing that the number plus h is getting plugged into, the number being the thing getting added to h. Once you identify these two things, you just take the derivative and plug in that number. So f prime of x is going to be, drop the power down like it's hot, negative x, negative 1 times x if you want to write. And then you just subtract 1 from the old exponent to form the new exponent. That's going to be minus 2. Again, we love the power rule, but we do need to do the additional step of changing things back. so that we can more easily find the actual number. So it's going to be f prime of 3 looks like it's going to be negative 1 over 3 squared, because x to the negative 2, 3 to the negative 2, that means take it to the denominator. And then what is negative 1 over 3 squared? I believe that's negative 1/9. So again, even with the h1s, not too crazy. Still identifying something, then identifying two things actually, a function and an a, take the derivative of that function, plug in the a, and we are good to go. So let's do a few more questions. Let's do one more non-h1 and then one more h1. So another time for erasing. Let's do this. Which one do we want to do? So let's do limit as, I want this to be my function. I'm going to have plus 1 here. Looks like I'm going to have x going to 1 as well. X minus 1. So this is going to be my guy right here. So again, this is a not h1, so it's going to be pretty easy, at least to identify. So we're going to identify on the side here. The function is just right here, cosine of pi x. So we'll write f of x equals cosine of pi x. And then the a, again, is also pretty easy. It's the number that x is approaching, or the number getting subtracted from x. So in both cases, it's 1. We can take 1 second to see if we identified the right things. How you do that is you plug in, or let's write a because we've been consistently using a. But what you do is you plug in this number into the function and you see if you get the negative of this number. This is a little bit confusing, but if you remember that first example, it was minus 25, so we wanted to get 25 exactly. So when we plug in here 1, we get cosine of pi. The angle pi deals with the point or corresponds to the point negative 1 comma 0 on the unit circle. Cosine is the x coordinate, so it's negative 1. So it looks like we do actually have the right number here because it's minus negative 1. So when we plug in 1, we get negative 1, so we get minus negative 1. So we have the right number. Hopefully that wasn't too confusing. If it was, remember that's just the checking step. It's not the most important thing. The more important thing is to take the derivative. So here we're going to take the derivative. The derivative of cosine is negative sine, and then pi x. And just remember, of course, please, anytime you're taking derivatives, you do want to be wary that you might need to employ the chain rule. And in this case, you do, because the derivative of the inside is times pi. The derivative of 2x is 2, the derivative of negative 7x is negative 7, the derivative of pi x is pi. Almost slipped there. So a lot of my students can do the chain rule when the question is just take this derivative, but they forget the chain rule, small chain rules especially, when the question is a little bit more involved, when a derivative is just part of the question, sort of like in this example, we have a limit where the derivative is part of the question, but hopefully you can still spot chain rule whenever you need to do it. So finally, what we're going to do is we're going to plug in 1 here. The number is not going to be too exciting. It's going to be f prime of 1 is equal to negative sine of pi times pi, because we plugged in x is equal to 1. Why is it not exciting? Well, again, pi does correspond to that point negative 1 comma 0 on the unit circle. I can draw it real quick if you want. It's this point right here. Sine is the y coordinate, so we have 0. So actually, if we brought out the chain rule, you would have gotten lucky, because it's 0 times pi, the answer is 0. But again, anytime you're taking derivatives, you always want to be wary of the chain rule. And in this question, we took a derivative because that's what we're doing in this process. Identifying a function, plugging a number into the derivative. So we have to take the derivative carefully. So let's do one more h1. So I'm going to erase this. One more h1. I believe in this friend. We can do it. So let's do this. Limit as h goes to 0. Let's do ln, because the ln is my friend. Not ln, but ln. Let's do 7 plus h minus ln of 7 over h. So another h1. Well, I wanted to do a little chain rule actually, but sort of failed in that aspect. Here, let's change the question slightly. We haven't started yet. Let's do ln of 2h plus 7 minus the ln of 14 over h. So forgive me for changing the question, but I do want to employ the chain rule. why don't you pause the video and actually try this question and use the channel. So 3, 2, 1, let's just see what you got. Let's just see what you got. So in this case, what's the function? What's the A? Well, I actually like to find the A first. The A is the thing getting added to H. So it looks like it's 7 here, H plus 7. So it's going to be 7 here. What is the thing plus H getting plugged into? That will be the function. So you have this H plus 7. What is it getting plugged into? If you want, you can cover it up with an X. Looks like it's ln 2x. So it's going to be, let me erase this real quick. Sort of sloppy at the end, but sometimes we get a little bit rushed. But looks like we still identified the right function. We can check ourselves. Well, when you plug in 7 here, you do get ln of 14. So it looks like we had the right function, the right number. One more time, let's take the derivative, plug in the number. So let's see if you took the derivative correctly. I believe in you. So the derivative of this function, ln, is 1 over that thing. So it's 1 over 2x. But you got to remember the chain rule, because the inside is not just x, it's 2x. So we do need to multiply by 2. These 2's cancel. How nice. So what's the last answer? Well, we just plug in 7, but plugging in 7 is actually very simple here. Looks like we are going to get 1/7. So this is the power of these questions, taking this awful limit. I don't even know how to do this algebraically. The only way I know how to do this is the calculus way, finding a function, taking the derivative, plugging in that number. So what I like my students to do is to be able to go backwards. So we're going to do that for a few minutes. We're going to start off with a function and a number, and we're going to write its derivative as 2 different limits. Just to end the question. Because sometimes you gotta look at the world the regular way, and sometimes you gotta look at the world upside down. So they say. I don't know who they is. So we're gonna have a function. Let's take the function f of x is equal to x cubed plus x. Let's take my favorite number, which I'm going to say is 2. And then what we're going to do is we're going to try to write f prime of 2 as 2 different limits. One like this and one like this. We're not actually going to try to take this derivative and plug in 2, though we could. This derivative would be 3x squared plus 1. We can do this on the side. It's not really the question, but it's 3x squared plus 1. You plug in 2. Let's use vertical bar notation. So it's 2, 4. 4 times 3 is 12. 12 plus 1 is 13. I believe that's right. 2 squared, 4. 4 times 3 is 12, yeah. But that's not the actual question we want. Again, what I want you to know how to do is try to write this function and this a as 2 different limits. And you can actually, this actually appears on the AP exam, for example. Sometimes in multiple choice, they'll say, here's a function, here's an a, here's 5 different limits. Which one is the derivative? So let's write the h1, the non-h1 first. So for the non-h1, it's x goes to a. In this case, it's going to be x goes to 2. Hopefully your limits are a little bit better than mine. Then you write the function, so it's x cubed plus x. Then you write minus f of a. We'll leave that to the side actually, let's do that later. On the bottom is just x minus the number, x minus 2. So we do need to have this guy right here. We do need to find f of a. How do you find f of a? Well, you're just going to plug in a into the function. So that's going to be 2 cubed, that's 8, plus another 2, that's 10. Looks like it's going to be x cubed plus x minus 10. So this is the not h way. X going to the number we want, function minus f of a over x minus the number, x minus 2. So the h way is not too bad as well. We don't even have to look at the function and the a to start off with because it always has h's right here. So it's the limit as h goes to 0, h. Then you take 2 plus h and you plug it into your function. Don't be scared that we have multiple x's. It's going to be okay. We're just going to take both x's and replace it with the number plus h, 2 plus h. Just to be 2 plus h cubed plus 2 plus h. So taking 2 plus h, plugging it into both of these, and then finally we're going to subtract off f of a because that's what the form says to do. So it's going to be minus 10 because when you plug in 2 into this function, you get this. So hopefully that this video has been beneficial to you. I don't know what I'm saying anymore, but hopefully you saw the relationship between derivatives and limits and derivatives. and you've sort of focused on the idea that we can change these awful limit questions to derivative questions by identifying a function, identifying an a, taking the derivative of the function, plugging in a. I don't know what all these hand motions are, but hopefully that makes sense. Of course, if you want more practice, we have a Girls Teach Calculus video, which I'll link in the description below. In that video, one of my former students goes through several of these questions, both non-H and H, some that involve e to the x, ln x, fractions, square roots, squares, trig, anything. Some that involve chain rule, of course. So be on the lookout for that. If you want more practice, I highly encourage you checking that out. That video is probably better than mine. She probably explains things more patiently and more thoroughly than I do. So be on the lookout for that. If this video was useful for you, of course, we would appreciate a like and subscribe. Hopefully we'll see you in our next video. Keep in mind that you can't use this process for every single limit. You only can use this process for limits of this form. So in the next video, we learn a very powerful way to do limits. That's of course L'Hopital's rule. So be on the lookout for that as well. So until then, thanks again for watching, and I hope to see you in that L'Hopital's video. Thanks again.